What's up, party people? First of all, do me a favor if you're watching this video, like, share, and subscribe, please. This is gonna be a quick live. I got a special request to do some support with proportional relationships within similar figures. And of course, it was an opportunity for some content. So I'm gonna get on here and do this live real quick. I hope everyone has had a wonderful day. Remember, you can send questions in the comments, and I'll definitely get back to those. So let's get right to it so we don't take up too much of your time. So notice it says, solve for x. The triangles in each pair are similar. So here we have two sets of triangles, but we're going to focus on this statement, this equivalent or this similarity statement that's made. All right, so it says triangle CBA is similar to triangle, and that's my handwriting looks like it's bad tonight. EFG. Okay. Now, when we look at these different triangles, notice I want to start with C. I'm going to say 1, B, 2, and A, 3. So then now I want to label this EFG that is similar to the same way. So E being 1, F being 2, and G being 3. Well, you might say, Mr. Harris, why did I do that? Because I want to make sure that in this similarity statements, remember, those sides and those angles are proportional. So if we redraw this, then now I want to put angle E here, right? I want to do this right here. All right, and we're gonna erase that one. I want it to be as perfect as possible. All right. So now when I relabel this, I want, remember, E is 1, so E here, F is 2, so F there, and then G here. Okay, so now we're able to create our proportionality statement. So EF, remember, is 70, and FG is 60. Okay, so now from there, we can create a proportion. So this proportion is going to be, we'll start with CBA. So I'm going to say 96 over 8 plus 8x is equal to 60 over 70. Okay. Now, there's a couple different ways you can write this proportion. You can also say 96 over 60, because those two sides are proportional, is equal to 8 plus 8x over 70. Okay. Either one of these proportions is going to give you the same thing. So now when we have these proportions, remember, we want to cross multiply. And when I say cross multiply, I'm meaning we are multiplying diagonally. Okay. So I create the equation now. 96 times 70 is equal to 8 plus 8x. And I'm going to put that in parentheses because it's now times that 60. We can put the 60 in the front as well. Either way, if we do the same thing over here, I'll say 96 times 70 is equal to 60 times the 8 plus 8x. Notice we're multiplying the same thing in either one of these equations. So whichever way works for you, use that way. All right, so then when I do 96 times 60, I don't have a 96 times 70. I don't have my handy dandy calculator, so I'm gonna use my phone. And so that gives me 6,720. Okay, and then that's equal to, now I've got to distribute this 60. Okay, so I got to say 60 times 8 plus 60 times 8x. Now we could write that as 8 times 60 plus 8x times 60 because of the commutative property. All right, so on the left side, I still have the 6,720, and that's going to be equal to 60 times 8 is 480, I believe. And then here I have 480x. Okay. Now from here, we want to get the x by itself. So it's simpler to keep the x on the right side. And then we'll take this 480 on the left side, the opposite of a positive 480. We're going to subtract it. And then we're going to subtract the same thing here. Okay, so boom, boom. These cross out, that gives you 0. So I'm left with just the 480x over there. And then let's see what 670, 6720 minus 480. That gives me 6240. 6,240. Okay. So now we can rewrite this. I don't have to write that 0. I could say 6,240 is equal to 480 times x. And then in order to solve for that, I want to divide both sides by the 480. All right. And then that's going to, these cancel. So I'm left with x on the right side. And I'm going to say 6,240 divided by 480. And it's going to give me 13. Okay. So now with that being said, x is equal to 13. Okay. So in number 1, x equals 13. And if you solve this one, I won't go through this one. It'll be the same thing. You still get the 6,720. And then you still get 60 times 8 plus 60 times 8x. Okay. So that's important to know about number 1. Remember, the most important thing is you first of all have to look at this similarity statement and redraw these shapes so that the corresponding angles and sides are in alignment with one another. So that's why I put the 1, 2, and 3 here. All right, let's clear this up and go to another one. So now it says the polygons at each pair are similar. Now, when you look at this, you can tell that the similar polygons, based upon the shape, they're in alignment. So we don't have to move number 2. Okay, so number 2, I can simply set it up. If I'm trying to find x, notice this shape, or this side right here, is proportional to this side right there. Okay, and then we can use, we want to definitely use this other side here, because we don't know, the 15 is proportional to the top as well of the smaller one, but we don't have a value of the smaller one. So we need to create our proportion based upon values that they give us. So here I can say 2x plus 2 over 21 is equal to 8 over 7. Or I can do it like this. I can say left side to left side over right, left side over left side equals right, right side over right side. So I can say 2x plus 2 over 8 is equal to 21 over 7. These proportions, when I cross multiply, they'll give me the same thing. So here, I want to cross multiply. All right, and I'm going to say 2x plus 2 and times 7, and that's going to equal to 21 times 8. All right, so now here, same thing, distributing. I got to multiply 7 times 2x. So I'm going to say 7 times 2x plus 7 times 2. And then 21 times 8 is going to give me 168. And then I just solve this equation. 7 times 2x is 14x. 7 times 2 is 14. And then I keep the 168. I got to look for the like terms. This constant of 14 is a like term with this constant of 168. So from there, I want to subtract that 14 because I want to put it over there with its family. All right. Boom. So 14 minus 14 is 0. So I bring down my 14x. 168 minus 14 is 154. All right. And so I have 14x equals 154. So we divide both sides by 14. And then those cancel out to leave just x. And then 154 divided by 14 equals 11. Okay. Same thing over here. If I cross multiply, you would get 2x plus 2 times 7, and then 8 times 21. All right. Let's clear that out. Number 3, we got to move around a little bit. Now, I'm going to do my best to draw this number 3 when I move or when I rotate it. So I'm technically rotating either one of these shapes so that I'm going to rotate this larger one, and I'm going to make it like this. Actually, let me do this part. I gotta erase something. Let's try it like this. So let's do it like this. Boom, 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 and boom. Now, mine is a little off. I'm still not happy with that. Let me draw this again. This time I'm gonna keep it, okay? So I have this part right here. I have this part right here. I have this part right here. And then I have that part right there. We're going to imagine that that's perfectly drawn. So notice this small part up top is 15. Next to the 15, we have the 30. And then we have the 35 here. Okay. So once again, we wanted to rotate that. Now we could, because this is a rotation and a flip. So now that we have this aligned, notice the x minus 8 is in alignment with the 15 because that's the small narrow part. The 6 is in alignment with the 30. Okay, and then the 7 is in alignment with the 35. So we have 3 lengths on both of them, right? And that's going to help us. Okay, so here I can say, since I'm trying to find x, I can say x minus 8 over, I'm going to choose the left side. So I'm going to choose this 6, and that's equal to 15 over 30. Okay. Couple different ways you could write this proportion, but I'm just going to go with that one. We could also, we could say x minus 8 over 7 is equal to 15 over 35. They still will give us the same solution simply because we have these sides that are proportional lined up in the proportion. So if I cross multiply this now, then boom, I have x minus 8 times 30, and that equals 6 times 15. Well, I know 6 times 15 is 90. Yep. And I want to distribute this. So I have 30 times x minus 30 times 8. Okay. So this gives me 30x minus 240 is equal to 90. Now, this looks a little strange, doesn't it? But it's still the same thing. I want to get this minus 240 over on the right side because that's its family. So the opposite of subtracting 240 is adding 240. Those cancel out. I bring down my 30x. Now I have this 90 plus 240 is 330. And then I divide both sides by 30. And I get x is equal to, boom, 11. Should be 11. 11 minus 8 is 3 over 6. Yep. And we can always, don't forget, this is something I forgot to mention. Whenever you get a solution, plug it back in. So if I do here, if I go back and I say 11 minus 8 over 6, I want to know, does that equal to 15 over 30? Well, 11 minus 8 is 3, and 3 over 6 is 1/2. 15 over 30 is 1/2. So I know that my solution actually is 11. Okay. And you would get the same thing. Like if I plugged in 11 minus 8 over here, 3 over 7, 15 over 35. Then 15 divided by 5 is 3. So 15 divided by 5 equals 3. And then 35 divided by 5 equals 7. Here, 11 minus 8 is 3 and then over 7. So we know that it works out. So always go back in and double check if you're ever in doubt. Okay. Last but not least, we want to do number 4. This is important down here, number 4, because these angles right here that are marked tells me that that angle is those angles are congruent. So that means the proportionality would look like this. I would actually have this small triangle here, and then I would have this larger triangle here. Okay, so here now I have the 12, I have the 9 because the congruent angle is there, and then now I have the x plus 18 over here, and then the 21 on the bottom. Okay, so now when I write my proportionality statement, I can say 12 over 9 is equal to x plus 18 over 21. Or I could say 12 over x plus 18 is equal to 9 over 21. Notice I have the 12 for the left side over the big left side, and then is equal to the bottom side over the bottom side. So make sure when you do your proportionality statement, you think about those things. All right, so now when I cross multiply these, I have 12 times 21 is equal to 9 times x plus 18. 12 times 21, I definitely don't have that in my head. So that equals 252. And then I want to distribute this 9. So 9 times x plus 9 times 18. And that gives me 252 is equal to 9x plus 162. All right. And I chose a very small spot to write this in. I apologize. Let me rewrite it over here. Well, let's see. Let's do it in the corner. So I want to subtract 162 there, subtract 162 there. That gives me 0. I bring down my 9x, and that equals 90. And then 90 divided by 9. So let's go back up here. If I do, let's rewrite this. 252 is equal to 9x plus 162. All right, so I subtract the 162 from both sides. And then that gives me 0. I have 90 equals 9x. And if I divide both sides by 9, I'm going to get 10 equals x. All right, let's double check it. Let's see if it fits into both of these. So here I would have 10 plus 18 on the right side over 21. And I want to know, does that equal to 12 over 9? Well, 12 over 9 is equal to 28 over 21. So we could do this a couple ways. We could divide all of these by 3. So 12 divided by 3 and 9 divided by 3. So I get 4 over 3. And then if I do the same thing, divide these by, actually these can be divided by 7 here, because that's the greatest common factor. 28 divided by 7 is 4. 21 divided by 7 is 3. So they do check out. All right. Same thing would happen over here if I had 12 over 10 plus 18. Does it equal to 9 over 21? So 12 over 28. If I want to see, does that equal to 9 over 21? Then I want to say, okay, well, what's the greatest common factor between 12 and 28? Was it 4? Divided by 4 there. 12 divided by 4 is 3. 28 divided by 4 is 7. And then here I divide these by 3. Boom, because that's the greatest common factor. And then 9 divided by 3 is 3. 21 divided by 3 is 7. So we see that they do check out. So key things to remember in this particular lesson. Let me clear this out. Remember to pause this, rewind it if you need to. But key things to remember when we're making these proportions based off of the shapes. If they give you a similarity statement, you want to redraw one of those shapes so that you can see where the proportional sides are in alignment, okay? And then once you do that, then you create your proportionality statement. And it can go from shape A to shape B in the first fraction is equal to shape A to shape B in the second fraction, or you can do the first fraction being shape A over shape A is equal to shape B over shape B. And when I talk about those proportional sides, remember it has to be the sides that are proportional. Once you create your proportion, you cross multiply, you solve for X. Just in case you always want to plug in the value of the variable that you get when you solve these, you want to plug it in and double check to see if it actually equals out in your original proportion. Thank you so much for watching. Remember, like, share, and subscribe. And remember, I got the solution to your math problems. Deuces.